my channel Learn, Grow and Rise. Hope all are doing well. Today we will discuss one important type of chemical reaction, that is redox reaction. I have already discussed all other types of chemical reaction in my previous video. If you want to see all these types of reaction, please check my description box. I have given the link in my description box. So today's video of redox reaction, we will discuss definition of redox reaction, oxidation reaction, reduction reaction, examples, oxidizing agent, reducing agent, types of redox reaction and applications of redox reaction. Now let us discuss what is redox reaction. Redox reaction can commonly known as electron transfer reaction and reduction oxidation reaction. The definition of redox reaction is redox means reduction and oxidation. The red part is coming from the reduction and the ox part is coming from the oxidation. When both the process of reduction and oxidation takes place simultaneously, the reaction is known as redox reaction. In this type of reaction, one species is oxidized and another species is reduced. The examples of redox reaction that taking place in our everyday life is photosynthesis, respiration, combustion of coal and production and use of fertilizers. So, what is reduction and what is oxidation? Oxidation and reduction can be defined in following ways. Oxidation means gain in oxygen or loss of hydrogen or loss of electron, and reduction means loss of oxygen, gain in hydrogen and gain in electrons. So, if we compare these two, you can see that oxidation reaction is completely opposite of the reduction reaction. So, reduction and oxidation, let us discuss one by one as per their definition. Reduction and oxidation in terms of oxygen. Oxidation means gain of oxygen in species. When magnesium react with oxygen, magnesium plus oxygen will get magnesium oxide, 2 MgO. You can see that in this reaction there is a gain of oxygen. So, when there is a gain of oxygen, the process is known as the oxidation. In what is reduction? Reduction is the loss of oxygen. For example, when we just reduce the water molecule, when it is reduced, it will give you the hydrogen gas plus oxygen gas. You can see that when you will take it, if you will balance it to water, will give you to hydrogen and oxygen gas. So in this process, water undergoes reduction because there is a loss of oxygen from the water to produce the hydrogen. So if you notice that in the reduction and oxidation process, there is a gain or loss of oxygen atom, not oxide ion. Now, let us discuss oxidation and reduction reaction in terms of hydrogen. Oxidation is the loss of hydrogen in species. Water is oxidized. If you will take the water, you will get the water molecule oxidizes to give you the oxygen gas. So, because in water, if you will remove the hydrogen, then you will get the oxygen gas. So, oxidation can also be defined as it is a loss of hydrogen in species. Otherwise, reduction is the gain of hydrogen. If you will see that when hydrogen combine with the oxygen, you will get the hydrogen peroxide. So, formation of the hydrogen peroxide takes place when hydrogen gas combine with the oxygen gas, you will get the hydrogen peroxide. So, in this process, oxygen reduced to form hydrogen peroxide because oxygen added or react with the hydrogen, there is a gain of hydrogen or addition of the hydrogen take place, so that hydrogen peroxide forms. If you will notice, children, you will see that there is a gain or loss of hydrogen atom, but not the H plus ion. Now let us discuss the oxidation and reduction reaction in terms of electron. In terms of electron means what is oxidation? Oxidation is a loss of electron species. The same reaction let us discuss, let us take. So when magnesium it combine with the oxygen, you will get the magnesium oxide. In the magnesium oxide, the charge on the magnesium ion is Mg plus 2 and charge on the oxide ion is O minus 2. So you can see that here magnesium changes to what? Magnesium plus 2 ion. So magnesium plus 2 ion, and it will just lose how the magnesium plus 2 ion form. When magnesium atom lose 2 electron, you will get the magnesium plus 2 ion. So this process is known as the oxidation, because oxidation is a loss of electron. Now let us discuss the gain of electron in a species. So gain of electron, oxygen is reduced to, gain of electron is known as a reduction. So in that, oxygen is reduced to form the hydrogen peroxide. If you will see that oxygen, when it reacts with the hydrogen, you will get that your hydrogen peroxide. In the hydrogen peroxide, if you will see the charge on the hydrogen peroxide is, that is the, in this case, you will see that oxygen, here the charge, because it is free, so the charge on this oxygen atom is 0. But the charge in this oxide is O minus 2. So oxygen form the minus 2 means oxygen atom here, that or oxygen gain 2 electrons to form the O minus 2. That is the minus 2 charge present in the oxide atom. So here the oxygen atom gain 2 electrons to form the minus 2. So this is the process of the reduction. Now let us discuss how can you identify a reduction reaction. Reduction reaction is that type of reaction where oxidation and reduction take place simultaneously. Next is that total number of electrons lost by one substance must be equal to the total number of electrons gained by the second substance. For a redox reaction to occur, something must accept the electron and that is lost by the another substance. So these are things, if you'll see, happens in one reaction. This means this reaction is definitely a redox reaction. Now let us discuss it through one example. What is oxidation? Oxidation is loss of electron and reduction is your gain of electron. You will remember the keyword oil for oxidation. Oil is you will remember for oxidation. So oil oxidation is loss of electron, and if you will just remember the RIG is reduction is gain of electron. So please remember these two keywords or two words to remember the oxidation and reduction. You'll remember oxidation is the oil, means oxidation is loss of electron, and reduction in terms of the RIG. RIG means reduction is gain of electron. Now let us discuss the whole thing in the terms of one example. Now let us take the sodium atom. Sodium atom forms sodium ion when it loses electron. Chlorine molecule or chlorine atom, you will see that here, not the chlorine molecule. So chlorine atom, it also lost electron. So one chlorine atom lost one electron. When the two chlorine atom you will take, two chlorine atom that lost electron, and you will get the chloride ion. So when the sodium and chlorine atom, when two chlorine atom combine, they form one chlorine molecule. When sodium it combine with the chlorine gas, you will get the formation is your NaCl. NaCl is formed by the Na plus and the Cl minus. In this process, you can see, or during the formation of the NaCl, you can see that oxidation and reduction, both the reaction take place together. You remember always, children, in the redox reaction, both the oxidation and reduction reaction take place simultaneously, and one cannot occur without other. Now, let us discuss few more examples. Firework displays. Do you know what is present in your firework? The firework mostly contain the magnesium. Magnesium atom, when oxidized, it form the magnesium oxide. In the magnesium oxide, you can see the magnesium. How we will write the magnesium oxide? That is consist of the Mg plus 2 ion and O minus 2 ion. The oxidation, the magnesium, it form the Mg plus 2 ion plus 2e. Means here is the loss of electron, means the process is your oxidation. When it is the process is oxidation, and we can say the magnesium atom oxidized, and when it is oxidized itself, then it is known as the reducing agent. And the oxygen that gain 4 electron, and it form the oxide ion, the oxide ion, and the gains of electron, and the process where the oxygen molecule gain 4 electron to form the oxide ion. So in this process, oxygen reduced to form the oxide ion. So the whole process is an example of the redox reaction. The whole process is an example of the redox reaction, because, children, you can see both oxidation and reduction occurs simultaneously. Now let us discuss what is oxidizing agent. An oxidizing agent is a chemical species that causes other reactant in a redox reaction to be oxidized, and it reduces itself. This means, in short, reduced oxidizing agents are substance that accepts electron. The accepts electron from where? From other substance. So the substance that is reduced. So what is oxidizing agent? Oxidizing agents are the species that oxidizes other but reduce itself. It oxidizes other, means it forces other to lose its electron. So when that other species that loses its electron, that species or that oxidizing agent that gain that electron. So oxidizing agent always accept electron. So that accept electron, always accept electron that is donated by the reducing agent. Now let us discuss what is reducing agent. Reducing agent is a chemical species that causes other reactant in a redox reaction to be reduced. So that what is reducing agent, children? Reducing agent always reduce others but oxidizes itself. So when it oxidizes itself, means the substance that donate electron, because it donate or lose the electron, because it oxidizes itself. Oxidation is a process of loss of electron. So it always lose the electron or lost the electron, and that lost electron must be accepted by what? By an oxidizing agent. Is it clear, children? So reducing agents are the substance which reduce others but oxidizes itself. Now let us see few examples that is act as an oxidizing agent. Acids, mostly acids are act as the oxidizing agent. Metal that react with the acids, that in that reaction you can see is an example of your oxidation and reduction reaction, and this reaction can be known as your redox reaction. So now let us take one example of that kind of reaction. Zinc react with the dilute HCl to give you hydrogen and zinc chloride. Now let us check this reaction. In this reaction, the zinc that is formed that Zn plus 2. When it formed the Zn plus 2, you can see that there is a loss of electron. So this process is your oxidation. Now you can see when the hydrogen is present in the H plus ion, because when HCl, in HCl the charge on hydrogen is plus and charge on the chloride is minus. So H plus ion that convert to hydrogen gas. When H plus ion, if you will balance it, so if you will multiply the atom, now the atom is balanced. Now you can see here plus 2 charge is there, and on hydrogen there is no charge, means it's neutral. So if you add 2 electron here, the reaction is balanced and charge is also balanced. So this process is your gain of electron. So the process is your reduction. So in this reaction you can see both the oxidation and reduction takes place simultaneously. Hence this is the example of a redox reaction. So in this type of reaction you can see zinc lost the electron, and that electron is gained by the hydrogen. So zinc is act as a reducing agent because it helps the hydrogen ion to reduce. So zinc is a reducing agent and hydrogen ion or H plus ion is act as a oxidizing agent. So remember children, an oxidizing agent is reduce itself and oxidizes other substance, and reducing agent is oxidizes itself but reduces others. Now let us know that few types of redox reaction. There are 5 types of redox reaction. One is a combination reaction, we have already discussed, decomposition reaction, displacement reaction, double displacement reaction, and disproportionate reaction. So now what are the application of the oxidation and reduction reaction, or you can say what is the redox reaction. Okay, so in everyday life, to clean or to bleach our clothes, sanitize our swimming pool by the chlorine, whitening our teeth by peroxide treatment, in the food and nutrition, redox reaction, burning the food we eat. Antioxidant react with the undesirable free radicals, or the process of digestion or respiration. The process of respiration where the food burn to give us the energy is an example of redox reaction. In industry, during the production of the iron, steel and other metals and consumers of the goods, we are using the redox reaction. So hope children, all of you understand the concept of the redox reaction very well. Please go through the video and take your notes while watching this. Do not forget to like, comment, share and subscribe to my channel. Thank you.